All right, so there's only 2 people that got an A in this class. There are some classes that nobody got an A. So we definitely need to replace this grade. A lot of us hurt our grades with this quiz. So what we're going to do is review the quiz itself, and then we're going to cover one more section. So we're going to have a quiz this Thursday over sections 4.3 and 4.4, but it will replace this quiz score if you do better on that 4.3, 4.4 quiz. All right, so we're going to review it because the same material is going to be on Thursday's quiz. So question 1 is, what is a GCF? So we should know, we should be able to look at all 3 terms and see what's in common, and you want to pull out the greatest common factor, right? So when you see the number 12, the number 6, and the number 18, some people might say, yeah, you could pull out a 2, which is true, but that's not the greatest value you could pull out. What's the greatest value you could pull out of all 3? 6, right? So everybody should have the number 6 that you're pulling out. And what else could you pull out? There's also x's. There's 12 right there, 6 right there, and 3 right there. And the greatest amount of x's you could pull out of all 3 terms at the same time would be an x to the 3rd. So your GCF is 6x to the 3rd. So that should be your answer right there, right? Since we're on topic of GCF, number 10 is another question. Same exact type of question, bless you, where we're pulling out the greatest common factor. All right, so what would the greatest common factor be here? 18, right? A lot of people see the 18, the 54, and the 36, and they think, hey, 9 works, right? A lot of people might have thought that 9 is the greatest value you could pull out because 9 times 2 is 18, 9 times 6 is 54, and 9 times 4 is 36. That is a common factor, but it's not the greatest, right? The greatest would be 18 itself. So if you were pulling out the GCF, you'd have an 18 out here, and your greatest amount of x's would be x to the 5th. So option D would be the correct answer there. Now, these next type of factoring questions, number 2, 3, 4, 5, all of them are quadratic trinomials with the a value of 1, okay? So they're all pretty much done the same way. If your a value is 1, that means that you could jump right into this factored format, and all you have to do is think what times what is your c value, that if you combine together is your b value. Okay, so I always say make a list, right? So how could you get negative 32? Negative 1 times 32, negative 2 times 16, negative 3 times doesn't work, negative 4 times 8, negative 5 doesn't work, and that's about it. 6 doesn't work. 7 doesn't work. So there's only 3 possible ways of multiplying numbers together to give you that c value of negative 32. So which pair of numbers combines together to give you the 12? Once you make your list, just start adding, right? What's 32 plus negative 1, or 32 minus 1? That's 31. That b value is not 31. When you go 16 take away 2, that's 14. That b value is not 14. When you go 8 take away 4, that's 4. That b value is not 4. So none of them work. So what does that mean? Not factorable, right? So it doesn't work. You say not factorable. Okay, which in this case would be option E. So the way I give the multiple choice is it says which of the following are factors. I might just show one, I might show both, so it is possible to get 2 answers. Would anybody like to see 3, 4, or 5? 5. Okay, let's take a look at 5. By the way, if you messed up on this, please do corrections on it in your notebook. Show it to me, get some extra 5 points, right? Just to bump up your grade a little, because you never know. I mean, it's better to have some points guaranteed. I would rewrite it in your notebook and just factor it in your notebook separately, okay? And also explain what you did wrong or the correct steps on how to do it right. So number 5, again, this is a quadratic trinomial with the a value of 1, which means that you could jump right into this. And all you have to do is think what times what is the c value, which is negative 6, that if I combine together gives me the b value of negative 5. Make a list. How could you get negative 6? Well, negative 1 times 6 is negative 6. Negative 2 times 3 is negative 6. And that's about it. Because when you go to negative 3, you're back to 3 times 2, and you already did the 2 times 3. So anyway, there's only two possible ways of multiplying numbers together to give you negative 6. If you combine these, does it give you a negative 5? No, it gives you a positive 5, right? So you have the right number, you just have the wrong sign, which means that you have the right numbers, you just have the wrong signs. So change that minus to a plus, change that positive 6 to a negative 6, and that's what goes right in there, a plus 1 and a minus 6, and that's it. Now, the question says, which of the following are factors of? Well, is there a x plus 1? Yeah, it's right there, it's C. So if you just put C, you got it right. Because if you look for x minus 6, it's not there. If you put x plus 6, that's incorrect. So just C, right? But there are some where you circle both, if they're both there. So anyway, numbers 3 and 4 are done exactly the same as the previous two because the A value is 1. Number 4, that's kind of challenging because the C value is 84, so you're going to have a long list right there, okay? Let me just get you started on that list. How could you get 84? 1 times 84. 2 times, get a calculator, go 84 divided by 2, be 42. 3 times something to give you 84. Get a calculator and divide 84 by 3, you'll get 28. And then 84 divided by 4, that'll be 21. 84 divided by 5 doesn't work. Divided by 6, 84 divided by 6? 14. 84 divided by 7, 12. 84 divided by 8 doesn't work. 9 doesn't work. 10. So that's about it. Those are all the possible ways. And again, because the A value is 1, you could jump right into the factored form format where you have the parentheses with your x right there. And you simply start combining, like 84 plus 1 is 85. That's not 85. 42 plus 2 is 44. That's not 44. So you want 19. When you combine 21 and 4, that's 25. That doesn't work. So what's going on here? 7 and 12. That's the only combo. Almost didn't see that. 7 plus 12 is 19. So you put that plus 7, that plus 12, and you're done. So right here is one of those cases where the x plus 7 is right there, so that's an answer. And the x plus 12 is also right there. So you have to put both of those answers on your answer column or circle both of them right there to get full credit. If you only put A, half credit. You only put C, half credit. Anyway, number 6 and 7. This is worth 2 points. Why? Because it's a multi-step process. You see, all the other ones had the A value of 1. Right here we have the A value of 6, right? So you have to use the steps. And step 1, if we don't remember, is to multiply A times C. So our A value is 6. Our C value is negative 3. So if I multiply 6 times negative 3, that'll give me a negative 18. And then step 2 is to think of the multiples of that answer, of negative 18. Make a list. So how could you get negative 18? Negative 1 times 18. Negative 2 times 9. Negative 3 times 6. Negative 4 doesn't work. Negative 5 doesn't work. And if you go to negative 6, you're already back to the 6 times 3, the 3 times 6. So there's only 3 possible ways of getting negative 18. Which of these pair of numbers combines together to give us negative 7? 2 and negative 9, right? This gives us 17. That's not 17. This gives us 7. That's 7, but it's negative. So we have the right numbers right here. We just have the wrong signs, right? So change that to a plus 2, change that to a minus 9, and you're good to go. Now this is where it gets weird. Step 3 is to rewrite your trinomial, your 3-term polynomial, as a 4-term polynomial by changing your middle value b to these 2 terms, right, from step 2. So in case you forgot, you want to rewrite your b value, this entire negative 7x, you want to rewrite that as positive 2x minus 9x. Okay, so let's start from the beginning right here. 6x squared, let's write that. 6x squared. Now the middle value, negative 7x, I'm going to rewrite that as positive, I'm going to rewrite that as positive 2x minus 9x. Let me do that in blue. Positive 2x minus 9x. And then this last term over here, the minus 3, you're just going to write it right there, minus 3. Okay, so the middle terms really do, when you combine positive 2 and negative 9, it really does give you that negative 7. So it's not like you changed anything. You just rewrote this, made it look a little different. You changed your 3 terms to 4 terms. Now, why would we do that? So we could now factor by grouping. Step 1 on factoring by grouping is to make some space between your first group and your second group. So the first group is 6x squared plus 2x. Second group is minus 9x minus 3. Okay. So after you make space between your first and your second group, what could you pull out of your first group? What's in common right there? What's the GCF of that first group? 2 and x. All right. Now what would be left on the inside? 2x times what would get you back to the 6x squared? 3x, And over here, 2x times 1 will get us back to that 2x. So we definitely need a 3x plus 1 in the parentheses. When you look at your second group, what could you pull out of that second group? A negative 3. Pull out a negative 3. And if you think about it, negative 3 times what will get you back to that negative 9x? 3x. And how about negative 3 times what will get you back to a negative 3? Just a positive 1, right? Negative 3 times positive 1 will take you back to that negative 3. So the final step on factoring by grouping is to factor out your common binomial. So the only way factoring by grouping works is if you end up with a common binomial right here, so you could pull them both, factor it out, okay? So I always use exaggerated parentheses. You don't have to, all right? I just think it's a little bit clear to whoever's watching me do it. So I'm pulling out the common binomial, which has red parentheses and has that blue binomial 3x plus 1 on the inside of the parentheses. So what would be left? Well, you'd have your 2x left over and your minus 3 left over. So just bring those two terms down, and you're pretty much done. That's your factored form. 3x plus 1 times 2x minus 3. And if you look for the multiple choice answers, is there a 3x plus 1 anywhere? So there is definitely a 3x plus 1. That's B. Now we move on to the 2x minus 3. And that's a 2x plus 3. There is no 2x minus 3, so it's not shown. So the only one that they're showing is B, so that's our correct answer right there. Now, of course, if it were an open response quiz or test and I tell you to factor, you need to show this entire binomial times binomial, okay? So that's the hardest one there is. That's why there was 2 points on this front page. Now, the last two are perfect square binomials, or at least we're dealing with those types of questions. Now, you cannot have a perfect square binomial that has a plus sign. It's just impossible. It doesn't work. So this is automatically not factorable. Unless you could pull out something in common. I always try to pull out something in common. You can't. But the reason why you can't do the square root method is because, let's think about this. If I do the square root of 25x squared, that's 5x. If I do the square root of 36, that's 6. So even if you started doing this, when you start distributing, the very last part of distribution would be the 6 times 6 to give you positive 36. And the only way you're going to get positive 36 is if this is a positive 6 and this is a positive 6, or if this is a negative and this is a negative. But we know that if you have both positives, you're going to get a middle term. Or if you have both negatives, you're going to get a middle term. And this one doesn't have a middle term. And the only way that the middle term would cancel out is if one's positive and one's negative. So because of that fact, this is just simply not factorable. Okay. If you were to guess at it and say, oh, plus 6, when you check, it won't work. You'll get 25x squared. You'll get plus 60x plus 36. And obviously, that middle term, 60, is not right here. There is no middle term. Even if you change them both to minus, that would just give you a negative 60x. And there's obviously no negative 60x. So this is definitely not factorable. And the last one, it is factorable because it is a minus right there. So when you apply the square root method, factoring this perfect square binomial, you have a 2x with the 3, a 2x with the 3. One has to be plus, one has to be minus. And it doesn't matter which one's which. But anyways, those are your factors. So number 8, it was not factorable. And number 9, A and B. That's right. Let's take a look at the back side of this thing. Okay, so a lot of us just didn't understand the backside, even though We had a lot of these questions even on the previous quiz also. When you have an equation, and not only that, guys, I tell you, solve the following by applying the zero product property. You need to know the zero product property. What is that? When you have something times something and the answer is 0, the first something could be 0 or the second something could be 0. So right here on number 11, we do not have something times something. We have something minus something and then plus something, but we don't have something times something. So we want to use a zero product property. We need multiplication. So that's why we're factoring, to be able to end up with multiplication. Now, this is a quadratic trinomial. The a value is 1, which means that it should be super easy. Put an x right there and an x right there, and think what times what is a c value that if you combine together is a b value. So make a list if you need it. 1 times 8, 2 times 4. Obviously, the 2 and the 4 give you that 6, but you want it to be a negative 6. So you're going to change the signs. So you're going to have a negative 2 right here and a negative 4 right there. And you still have this equals 0. It's still there. All you did was change this trinomial to a binomial times a binomial. You did reverse distributive property. You factored. So zero product property says that if you have something times something and it equals 0, this first one could be set equal to 0. X minus 2 could be 0. Or the x minus 4 could also be 0. Which means that when you solve each of them, plus 2, x equals 2. Over here, plus 4, x equals 4. That's an ugly 4. There we go. So on all of these in the back, you should have split them and solved. That's what the zero product property is all about. Some people left their answer like this. They just wrote that as their answer. When you factored it, yeah, but what's the purpose of factoring? So you could actually split them and solve and get your 2 answers. Number 12, that was the exact question from the previous quiz. Does anybody need to see this one? Yes, okay. So on the instructions it says use a zero product property. Again, the only way you could use a zero product property is if you have something times something and it equals 0. Right here it's not equal to 0, so the first thing to do is to make it equal 0. Let's subtract 4x, rewrite it, 7x squared minus 4x equals 0. Okay, so now the question is, could you factor the left side of this equation? Now, you might be thinking, well, my a value is not 1, so I need to do a times c, and the c value is not there. I'm confused. Don't do that. What's the first type of factoring you should always try? GCF. So is there anything in common in this first term and this second term? Yeah, there's definitely x's. So put parentheses, pull out that one single x. What do you have left over? You have the 7x, not x squared anymore, it's just x, and then a regular minus 4. So you've factored out the GCF, which happens to be x, and it's still equal to 0. So what we're going to do now is simply separate them and solve. Using the zero product property, we're going to split them. This x could be equal to 0, and this 7x minus 4 could also be equal to 0. Now you need to solve both of them. Right? The only difference is that right here it's already solved for you. It's even easier because they're telling you, hey, the answer is x equals 0. And on the other one, it's 2 steps, right? Plus 4, you end up with 7x equals 4. Final step would be to get rid of that multiplication of 7, divide by 7. You end up with x equals 4/7. So those are your 2 answers. If you only wrote one of them, you only got half credit. You needed to write both of them, okay? So always try to pull out a GCF first, and then if that doesn't work, try other factoring methods. 13 and 14, bless you, 15 and 16, these next 2 were pretty much the same deal. They're quadratic trinomials. You first have to get rid of the number 3 and the number 24, set them equal to 0, and then you factor, split, and solve. The only difference between these guys and the previous ones or that the a value is not 1. There's a 12 on 15-16, and there's a 5 on 13-14. So those are definitely more challenging, and that's why they're worth a lot more points, right? They're twice as much as the other ones. So instead of doing both, which one would you like to see, 13-14 or 15-16? 15-16, sure, why not? Okay, so let's zoom in on this guy. And again, the instructions say use the zero product property. So let's first make it equal 0. Subtract 3, rewrite it, 12x squared plus 5x minus 3 equals 0. And then let's go through our steps. Step 1 is to multiply a times c, which is 12 times a is 12, c is negative 3. It's going to be negative 36. Step 2 is to make a list of the multiples of negative 36. Start with the most basic, negative 1 times 36. Negative 2 times, use a calculator if you need to, 18. Negative 3 times 12. Negative 4 times 9. Negative 5 doesn't work, and negative 6 times 6. Those are all the possible ways of multiplying two numbers together to give you negative 36. The question is, which of these pair of numbers combines together to give us the middle value, which is positive 5x, with the b value? So let's start combining and checking. So this, if I combine these guys, it gives me a 35. That's not a 35. I want a 5. This gives me 16. That's not a 16. This gives me 9. That's not a 9. This gives me 5. That is a 5. I don't need to change any signs. Winner, winner, chicken dinner. Here we go. That's the answer. Negative 4 and positive 9. Okay? So the next step is the weird part where you rewrite your trinomial as a four-term polynomial. Let's begin with the 12x squared. 12x squared. Now this b value of 5 with the x, we're going to rewrite it as the negative 4x plus 9x from step 2. So let's do that. Minus 4x plus 9x. That was from step 2. And then at the very end, we still have the minus 3. And technically, this is still an equation that's equal to 0. You could ignore the equal 0 for now, but once you factor it, you have to slap it back on there so you could split it and solve. So anyways, if you want to save some time, you don't even have to rewrite it. You don't even have to rewrite it. You could just say, what am I going to pull out of that first group? Definitely an x, but what else?
4.
A 4 as well. So 4x is the GCF of the first two terms. So if I pull out a 4x, what's going to be left over in here? 3x. And then what's going to be 4x times what gets us a negative 4? A negative 1 or a minus 1. Perfect. Okay, now, man, I hope I don't confuse anybody by not showing the first step of separating them. What could I pull out of these two terms right here? A 3. Okay, so let's pull out a 3. And what kind of 3 is that? Is that a positive 3 or negative 3 that we're pulling out? Positive. Okay, so put a plus in front of it just so it'll make sense later. What would be left on the inside? If you think 3 times what gets us a 9x? 3 times what gets us a 9x? 3 times 3 with an x gets us a 9x. And then 3 times what gets us a negative 3? A negative 1. Okay, so I factored the 4x out of the first two terms. I factored a 3 out of the second two terms. And now I'm going to take a step back and factor that common binomial out of both terms. So that common binomial will be 3x minus 1. And what would be left over on the inside? The 4x and also the plus 3. I did not exaggerate parentheses right there. I just did that to save some space. I hope everybody understands that. So this is now the factored form of the equation. However, they're asking us to solve the equation, and we need to have this equal 0 right here. The whole purpose of factoring is to get something times something, but it's still equal to 0. So bring down that equal 0 right there. And now you could apply that zero product property that states that if you have something times something equals 0, the first something could be 0, or the second something could be 0. So you're going to have 3x minus 1. That could be 0. Then you have the 4x minus 3. That also could be 0. So when you solve them, plus 1, you're going to end up with 3x equals 1. And your final step would be to divide by 3 to get that x by itself. So x equals 1/3. That is one answer. Then plus 3 over here, plus 3 over there. We end up with 4x equals 3. Final step would be to divide by 4. Divide by 4. The other answer is x equals positive 3/4. You have to have both answers to get full credit. And the last part of this quiz was simplifying radicals. The Casio calculator did this one for you if you just typed it in exactly the way it was. But the idea is that you know that when you have a non-perfect square number in here, you want to rewrite it with multiplication to get a perfect square number. So you could say 4 times 8, but what's a better perfect square number to break this down to?
16 times 2.
16 times 2. All right, so if you put 16 times 2 instead of 32, when you split it, you'll be able to do the square root of 16, which is a nice, beautiful answer 4. Now, that square root of 2, you just bring it down. Now, what about this guy out here? There's a 3 that's being multiplied out here in the front. Just simply bring this 3 down. So you're going to have a 3 times the 4 with the square root of 2. So the final answer right there would be 12 square root of 2. Number 18. So many people messed up on this one. I thought it was pretty straightforward, pretty easy. Apparently I was wrong. You see, a square root really means the power of 1/2. So we want these guys to be divisible by 2, right? Like if I told you, if I asked you, what's the square root of x to the 8th? That'd be x to the 4th. If I asked you, what's the square root of x to the 20th? That'd be x to the 10th, right? So it's easy when it's an even power because you simply divide it by 2. But if it's odd, well, you want it to be even. And whenever you don't have what you want, you rewrite it with multiplication so you could get what you want. So that x to the 7th, let's make it look like an even power. Instead of x to the 7th, let's rewrite it as x to the 6th with an extra x. Okay, a lot of people rewrote it as x to the 4th times x to the 3rd. That doesn't work, right? Because x to the 3rd could be broken down further. So let's go for the highest even power that you could rewrite it as, which would simply be 1 before that 7, which is x to the 6th. You put that extra x because x to the 6th times x takes you back to the x to the 7th. Anyways, we rewrote it with multiplication to get that even power. Now when I split it, I could actually do the square root of x to the 6th, that's x to the 3rd, and the other one you can't do, so you just bring it down. That's your answer. That's what you should have had on your answer column. X to the 3rd, square root of x. Anything else is incorrect. Okay. Now 19 and 20, this is solving quadratic equations by applying a square root. And this is actually a part of the next section that we're going to be covering anyway. So it's really good that we understand this right now. So first, let's isolate the x. Now think about it. Some students tell me, why don't you distribute? Well, distribution is multiplication, and you have to deal with exponents before distribution, before multiplication. PEMDAS has the e before the m, so you cannot distribute that 5. Why? Because there's an exponent on there. So it's better to get the x by itself on one side. That's what solving is all about. And how do you get rid of something? You do the opposite, right? So right here we really have a 5 times. To get rid of that multiplication of 5, divide by 5, divide by 5. You're going to end up with x minus 3. There's still a square on it, equals 4. And now to get rid of the square, you can't get rid of the minus 3 yet because you're squaring it, right? So let's get rid of the square first, and then we could worry about getting rid of that minus 3. So how do you get rid of a square? You do the opposite of a square, which is a square root. And what you do to one side, you must do to the other. Now this is what we need to remember. Whenever we apply a square root in an equation, you have to put a plus or minus in front of your answer. So here's the equal sign. I need to put a plus or minus right in front of the answer 2. The square root of 4 is 2, but I need to put a plus or minus sign right in front of it. Now the square root and the square, they eliminate themselves. So what do I have left? An x minus 3. All I need to do now is get x by itself on one side. Some students left that as their answer. I couldn't give full credit. You want to solve for x. You want to get rid of that minus 3 by doing the opposite. Plus 3, plus 3. And when you add 3 to a plus or minus, it's better to rewrite the whole thing. X equals the positive 3 plus or minus 2. Now, because you have two nice regular numbers, you could actually do both situations, the plus 3 and the plus 2 and the minus 2. So let's do exactly that. We have the 3 plus 2, which gives us 5. And we also have the 3 minus 2, which gives us 1. So that's the answers to number 19.
So if we just left it like that, it's half credit?
If you left it like that, I'd give you half credit. I mean, just because I was really picky on that. You shouldn't do that. If you could ever add or subtract numbers, you might as well do it. Now, if you had a radical in there, then yeah, you'd have to leave it as a plus, minus, whatever you have right there with the radical, with the square root. I think number 20 would be the case right there. So let's take a look at number 20. Let's get rid of this. Let's rewrite. After that, let's get rid of the 2. What do we have left? 64 divided by 2 is 32. Final step would be to get rid of the square by doing the opposite of a square, which is a square root. And I am applying a square root in an equation, which means that in front of my answer, I have to put this plus or minus. Now, here's the deal. The square root of 32, I wish that were a 36 so I could have a plus or minus 6, but it's not a 36, it's a 32. I can't really get a nice answer, but I could simplify it. You could simplify it on the Casio calculator, or you could say 32. What could I rewrite that as so I could get a perfect square number involved with multiplication? So that would be 16 times 2 is 32. That way when you split it, you could actually do the square root of 16, which is 4. The square root of 2 comes down. So rewriting the square root of 32 as 4 square root of 2. So in front of the right side of your equation, you have plus or minus 4 square root of 2. And on the left side, you have the x plus 1 because the square and the square root eliminated. So your final step, if you left it like that, it's not full credit. You have to still get rid of that plus 1 by subtracting 1 and subtracting 1. So your final answer will be x equals negative 1 plus or minus 4 square root of 2. That is your final answer right there. Hopefully you got that right. Ladies and gentlemen, these exact type of questions, I'm not going to say exact questions, maybe some of them will be exact, but the exact type of questions will be on Thursday's quiz. But we're also going to add on one simple section called complex numbers. Sounds complex, but it's not. We're going to do complex numbers tomorrow, and then we'll have a quiz that both covers 4.3 and 4.4, and that could change this grade. So if you got an F on this, and you get an A on Thursday's quiz that has this section in there, I'll change your F to an A. Sound good? Okay, if you're like, no, I want to retake this particular exact quiz, then talk to me. You could come in before or after school to retake this this quiz, all right? But I would just wait till Thursdays because it's going to be the same stuff and it could replace your grade.